So the standard treatment of milk fever is calcium, as milk fever is also called as the hypocalcemia, means decreased in calcium. So we have to provide calcium to that animal uh, to treat the milk fever or hypocalcemia. How much calcium is the question? So the question and its answer is 10 gram. And there is another problem that calcium is not available as pure form. 100% calcium is not available. It is available as mixture or compound of calcium gluconate or calcium borogluconate. Calcium gluconate and calcium borogluconate. Calcium gluconate is a compound, is a molecule. If we add boron to the calcium gluconate molecule, then it becomes the calcium borogluconate compound. And there was another compound that was used previously, that is calcium chloride. Calcium chloride molecule was used previously, but it is not used now, or it is not used very much. Now we use calcium borogluconate or calcium gluconate. Or today we will calculate that from these three compounds, we can say that calcium is not available 100%, means calcium gluconate will not have 100% calcium. Calcium borogluconate and calcium chloride will not have the 100% calcium. So how much calcium is available through these compounds, or through these compounds? So we will calculate this. So in order to find out the answer of this question, first of all we should have to know what is the molecular formula of calcium gluconate or calcium borogluconate or calcium chloride. We will solve first with the calcium borogluconate, that how much calcium is in, we will find in percentage, that how much percentage of calcium is available in calcium borogluconate. What is calcium borogluconate? Calcium borogluconate is the mixture of calcium with gluconate, and gluconate has the boron, carbon, hydrogen. Now let's start the calculation. So first of all, uh, how we will calculate? First of all, we should have to know the molecular formula of calcium borogluconate. We can find its molecular formula through pub chemistry. Pub chemistry or PUBCHEM. It's NCBI authentic website. Its molecular formula is C12H20B2 carbon and oxygen 16. So we can calculate by ourselves, or we can ask through AI tool, that if the formula of calcium borogluconate is C12H20 boron 2 calcium and oxygen 16, then calculate the percentage of calcium in that. So why we have told chatbot that if formula is that, because different formulas are used, it can detect different formulas for a same complex compound, but we will discuss it later. So it is the standard formula of calcium borogluconate. And how we will calculate that, how much calcium is in that. What we will do, we will divide the atomic mass of calcium with the molecular mass of calcium borogluconate and multiply it with 100, and we will know that how much is the calcium is in that compound. So you know that calcium molecular calcium atomic weight is 40, and it is only one atom in this molecule. So what we will do, we will divide 40 divided by molecular mass multiply by 100. So what is the molecular mass of that compound? We will calculate, we will calculate this by, for example, carbon is 12. There are 12 atoms of calcium in this compound. What we will do, we will multiply 12 with 12, as 12 as the atomic mass of carbon is also 12, means that in this compound 12 times Avogadro number uh, of atoms are present in this. So we will multiply 12 with 12, and hydrogen atomic mass is 1. So we will multiply by 20, multiply by 1, as 20 atoms are present in this molecule. So we will multiply 20 multiplied by 1. What is the 1? 1 is the atomic mass of hydrogen. And boron atomic mass is 10, and we will multiply by 10 multiplied by 2, like that, 10 multiplied by 2. And calcium is 40, 40 multiplied by 1, and 16. Oxygen are 16 atoms are over there, so we will multiply 16 multiply by 16, because atomic mass of oxygen is 16, and there are 16 molecules. 16 multiplied by 16, calcium 1 multiplied by 40, 10 multiplied by 2, 20 multiplied by 1, and 12 multiplied by 20. 12 multiplied by 12, it will give there how much is the molecular mass of that compound, and we will 40 divided by, as calcium is 40, 40 divided by that molecular mass multiplied by 100. So let's do calculation. So this is the calculation. 12 multiplied by 12. First of all, the first values within each bracket, 12, 22, 1, and 16. What are these? The exact values. What are the values? These values are these one. How much atom are in that compound? 12, 20, 22, and this is the one. This will be the one, and this is the 16. This is the 16, and the second value is the atomic masses. Atomic masses of each atom. 12.1, 1.1, 10.8, and up to 16. And the after solving this, we will add all of this. The molecular weight is the 482.02 gram per mole. So means 1 mole will have 482 gram of calcium borogluconate, and we will divide it with the percentage of calcium with the 40 and multiply by 100. And for example, let's assume that the molecular mass of uh, calcium borogluconate has calcium as 2, Ca2, O16, and other values are same. So what we will do, we will 40 multiply by 2, and we'll continue this equation, and we will find out the answer. So the question is that why I told the ChatGPT that if formula of calcium borogluconate is that, uh, the answer is that the calcium borogluconate, the AI can detect its molecular formula to be different. So in previously I have asked the ChatGPT to find out the molecular to calculate the uh, molecular weight of calcium borogluconate. So what it has done? It has done how to determine milligram, no, not that much. It has detected the formula of calcium borogluconate to be calcium C6, C6, 6 multiplied by 2 will be 12, 11 multiplied by 2 will be 22, means hydrogens are 22. And what are the hydrogen? Hydrogen are 20. Boron is 2. I think boron it has detected, right? No, it has not detected the boron. It has not detected boron. What it has considered? It has considered the calcium gluconate to be the calcium borogluconate. Instead of finding the value of calcium molecular mass of calcium borogluconate, it has find the molecular mass of calcium gluconate. So it has done the error. So the value is also, result is also different. It has given the final result to be the calcium is 9.3% calcium by mass in calcium borogluconate, but this is not the exact, it's not the correctly correct. It is 9.3% of calcium is in the calcium gluconate, not in the calcium borogluconate, because it has fetched through online data that the formula of calcium borogluconate is same as calcium gluconate, so it has done that error. So then we have corrected the AI boot that the formula of calcium borogluconate is that one, and we have checked that through the pub chemistry. Pub chemistry we have copied that, and we have told the that AI boot that now do the calculation, and later on it has done the correct calculation that the percentage of calcium in of calcium atom in the calcium borogluconate molecule is 8.31%.